All right, cool. So today we're talking about coroutines. I'm just going to quickly go over what we missed because we forgot to record. Basically, what we just done, I was talking about how you can use update to move things. So I just had this simple little function that just moves an object upwards. But the downside of this is that it's tied to the frame rate. So if you wanted to do something that involves calculating like something big in this update function, that would slow down the movement of this transform. So what we want to do is kind of decouple that movement from update so that it can be called independent of frame rate or independent of a bunch of different things and kind of evaluate over time across multiple frames. So that's what a coroutine is used for, is to do things across multiple frames. You can imagine also, say you have like a file that you want to download in the background, you could call a coroutine that allows that to, because say if you want to download like a gigabyte worth of data, you don't want to do that in a single frame because that'll just pause your frame until that's done. You'd want to call a coroutine that does all that processing in the background. Or it's good for like animations as well if you want to like transition over multiple frames. Basically, just like anything you want that happens over multiple frames, a coroutine is very useful for. Anyways, so how you actually make a coroutine? 1 second.
Question: are coroutines like threading? Oh, you can read
not
it.
Not exactly. So threading is more tied to like splitting up computation within like a single frame, whereas coroutines are essentially like setting a specific task to be completed and then kind of notifying once it's completed. So it's more sequential. Like all coroutines that you define are executed on the same thread. I believe. Don't quote me on that, but I believe that's how it's done. And then threading is more in the traditional sense of like splitting up tasks. So coroutines are more used for spreading out a task over a longer duration. So in the sense of Unity, at least, like in general programming, there is like a more definite distinction, but in the context we're talking about here, that's what coroutines are used for.
And also, like, if at a surface level, like if you don't really want to get into the details, a TLDR answer is like they are kind of like threads. Like in a lot of ways, you would use them in the same way.
Yeah.
But as Mark said, like it's actually not the same thing, and there are uses that you would use coroutines for that you wouldn't use threads for.
Yeah, and there's certain things you use threads for. I mean, that's like more of a technical question. I'm going into too much detail already. So short answer, no, but yeah, anyways. So let's make a coroutine. So as I said before, you want to make an I enumerator. So this is just a variable that's built into C# that just how coroutines are defined within Unity. That's just the type that they need to be. So for example, I'm just going to make a function called move_to, and we'll take in 2 inputs. So you can define pretty much any function to be a coroutine. So in our case, what we're going to do is make it so that we have a move_to function that takes in a position as a vector 3 and a speed of how fast we want to move. So we'll just do vector 3 position, or I'll do destination actually, if I can type it. Yeah. And then a float speed. Okay. And then we fill it out like a normal function. And here's kind of the cool part of how enumerators work. So you can imagine like if I were to put like a while true loop in here, that's a really bad idea because we're in an update function. This is never going to end because it'll call on one frame and then the whole program is just going to get hung up on that frame because this whole sequence of code is just never going to stop executing. So the nice thing about enumerators is you can actually use infinite while loops or like indefinite while loops inside of them. So what we're going to do here is I'm just going to say while our transform dot position is not equal to our destination, we're going to do transform dot position equals vector 3 dot move towards, and then we'll take in our current position, which is transform dot position, our destination, and we'll do speed times time dot delta time. So what this last bit is doing, so if we hover over, you can see, I'll zoom in the code a bit too. You can see move toward takes in the current position, the target position, and a distance delta. So what all this is saying is we have some specified speed that we pass in, and then what we're doing is just multiplying by the difference between two frames. So that's time.delta time. So the previous frame to the next frame. So that just kind of makes it so that regardless of your frame rate, it'll always move at the same rate. So I don't need a space there. And then here's the actual trick with how coroutines work. So you'll notice we still have an error here because I don't have a return value. So what you actually do to return with a coroutine is you type in yield return, if I can type, and then whatever value you want to return. So in this case, we're just going to return null. So what this is saying is essentially that when the frame ends, or when we want to call a new frame, instead of just continuing with this while loop indefinitely until this is finished, we're going to say that this function can actually yield its control of whatever thread it's on, so that the next frame can be called. And then once the next frame is called, it'll pick up where it left off. So it is kind of like threads in that regard, where you can kind of detach it and then reattach it and continue running it from wherever it is. But essentially, all we're doing is allowing this while loop to complete over multiple frames. So we're allowing portions of it to, or essentially what happens is it'll run this chunk of code here. So it'll do one little motion, and then it will yield until the next frame is called. And then this while loop will force it to keep running until the coroutine is over. And every frame it yields its control so that something else can run. Are there any questions about that? I kind of sped through that explanation. So.
Could you explain that yielding part again? Sorry, I was a little confused.
Yeah. So we start by calling a frame, right? And let me actually, let's say, well, I'm actually going to call this a numerator because that'll make a bit more sense. So I'm just going to do, let's see. 1 second, I have to check my
start coroutine.
Yes.
Move to
coroutine, and then we'll do move to of, let's just say vector 3 of like 10, 10, 0, and a speed of 5.
Vector 3, I think, right?
Yeah. Thank you. Cool. So if we save this for now, pop back in here, let it load. There we go. Now if we zoom in on our cube, we should see him or her shoot off towards that specific position. Yeah, so you see it slowly moves over to 1010. So if we look over here now, its position is at 1010. So what's happening here is rather than how update works, where it's calling update every single frame, what happened is we first at start, so right when the game starts, we call start coroutine, which calls this function. And then in this function, we have a while loop. So on the first frame, it'll look at this while loop and say, okay, I'm in this while loop because I'm not at my destination. I'll call this function. And then after calling that function and then executing it, I'm going to yield my control until the next frame. So essentially, this whole function stops running and then lets everything else run in that frame. And then when the next frame is called, control is given back to this function, and it picks up where it left off. So it'll go back to the while loop and then continue running this code over and over again until eventually this condition is met, and then it escapes the while loop, and then the function is done running. Does that make sense?
Yeah. So then I have the question. Why, or couldn't you also do this in the update function with like incrementing, like based on how long it's been from the previous frame? I don't know. That's how
yes,
I've always done it.
Yes, you can. The whole point of doing it this way is that it's much simpler, and you don't have to keep track of like all the stuff that you would need to if you're doing that, because like also you'd have to do the computation every time an update to figure out whether or not like you still need to be moving, and presumably update could have a lot of other stuff that's going on in it. So yeah.
Yeah, the benefit is that, like, for example, if you want to do that for a single object, you need to have some kind of timer keeping track of like what difference you have, You need to keep track of a bunch of different variables. All these different things add up in that specific object. And imagine you had like 10,000 objects in the scene. This method actually is computationally more cheap, I guess is the word I'm looking for, than doing that individually for each of those. I believe. I should probably fact check on that, but my understanding is that this is just a more efficient way of handling for like a large number of cases like that.
But wouldn't this also be called once a frame? Like update is called once a frame, and this one, I guess if you're using time.delta time, it's once per frame, right? And if you
It
just
still is
like
called once
pasted
per
this,
frame.
sorry.
It still is called once per frame, yeah.
Right.
So I guess this is a poor example just because like you can actually do this pretty easily in an update function. But this is just like a simple example. But you can imagine.
I just don't understand that if you're calling this once per frame and also update once per frame, and you could just directly pretty much paste this code into update, why would this be less computationally expensive than update?
The details well enough to like answer that to a technical level, but
Okay.
at least from the like brief research I did about this, it is overall better. So I apologize I don't have a better answer than that.
It's the reason that you're having trouble understanding is that this particular example doesn't really fit like the reason that you would use coroutines specifically for computation like saving, because we're only doing a single line of code here. However, if you were to do something like as Mark was mentioning at the beginning, if you had to do something that was like a billion lines of like a while loop that iterated a billion times, and like let's say it's not necessarily something that you would show an actual thing happening on the screen, if you put that into update, you would have to wait for that entire billion iterations to go through on one update frame, which, as you guys have probably seen in a video game, ends up with your with your frame just freezing right there because the game says, oh shoot, I'm doing an update. I need to get through this entire update call before I can move on to the next frame of the game. So if you were to instead break up that billion iterations into an enumerator like this, where it says, hey, on, let's say every 1,000 iterations, we'll put in a yield. So that means each frame you would only need to go through 1,000 of your 1 billion iterations of the while loop. And presumably this while loop is not something that you need to actually get done during one frame. So in that way, the player would not perceive any kind of like blip in their game, despite the fact that you're doing a lot of computation over the course of a lot of different frames, rather than putting all of that computation into one frame.
Oh, okay. So you can call yield return null, and on the next frame, it would just resume the code where you yielded it?
Yes.
Yes, exactly.
Oh,
Which in this case, because we're in a while loop, it just loops back to the while loop.
Right. Okay. I thought it kind of like restarted the entire function, so that's why I was having trouble.
No, yeah, I explained that kind of poorly. But like, if we were to have some code like do something here, and then I did yield return null, and then do something else, it would run that first chunk, yield, and then do the next thing
on the first frame. So if you had like 10 different things in here, it would do them frame by frame. And my next question is, how does it know to do it like once per frame?
That's just how it's implemented within Unity.
Okay, so it's a Unity specific thing.
Yes.
Oh, okay. And I had another question. Oh my god, I have a lot of questions.
It's all good. This is a complicated
questions are good. Yeah.
Sorry.
No,
I just ask too many questions every time I come in here. Once this function ends, will it automatically like restart the function or something, or will it?
It's just over at that point.
Will it just end?
It's like a normal function call, except you allow it to happen over multiple frames, essentially.
All right. Cool.
So imagine that it's just like a normal function call. So yeah, and like in this case, we're just using it to spread all of these calculations once per frame. Whereas like, of course you could just use update for that, but in our case, we're just using it to make it is a bit of a contrived example. Is again
also something else you guys should be aware of is that the reason it goes frame by frame is because I believe that's the default that the start coroutine like handles the null return value. So IEnumerator, you can actually return different types of things besides null. For instance, the one that I'm familiar with is the wait for seconds function returns a different type of IEnumerator, which is going to tell you, hey, resume this coroutine this many seconds into the future. So if you wanted to create a delay specifically on something that you were doing in a loop like this, that would be a different option of an IEnumerator to return. So you have options on how you want your coroutines to like go over. It's just like this frame by frame is the most basic example.
Yield, return, new, wait for seconds. All right, that's cool.
You can do something like
I think you have to say new, wait for seconds.
Yeah, I believe new.
Yeah. I always forget that.
I was just reading on it on the Unity documentation right now.
So if I were to pass in, let's just do in start, I'll define like words. Word I cannot type equals hello. I don't know. Anyways, we have a list of strings. We can pass it into here, and then we could do something like for each word in words. Wait, is that? I forget the syntax.
I think you need to define like word as a string. So for each open parentheses string words. Word.
Sorry, I've been writing a lot of Python recently, so I'm like getting mixed up.
Python is so convenient in every way. Also Python.
I also think you might in might not be the correct. You're totally writing Python right now.
Yeah, I think this works in C#. All right, we're doing it live. So I can do something like this. I think. Let's try this out.
If in is highlighted by the IDE, it's good enough for me.
Yeah, that's kind of how I'm feeling right now. And then I'll do
debug.log maybe. Yes, start coroutine.
And then text of words. Okay. So.
Oh, you'll check it in the.
Yeah. Okay. What do you think this should do? I guess I'll just ask first.
Print the next word every 0.5 seconds.
Exactly. So assuming I wrote it correctly, if we go back here and run it and then check our console, crossing my fingers. I need to do console.log, huh? Is that it? I think.
Might be capital. I only know debug.log.
Yeah,
I think it's debug. Yeah.
Debug.log.
I'll do that.
Almost every single line you wrote there was Python at first.
Guys, it's clear that I've been writing a lot of Python. Anyways, I swear I know C#. Oh, wait, here. All right, yeah, it did work, but I was not on the right thing. Let's just restart it again.
Didn't even realize C# had the whole for each thing.
It's very useful. But yeah, so you saw there that it every half second pasted the next thing into the console there.
Can you just like show it again, but change the?
I'll do this as like 1.5. Where am I? There we go. Cool. So we can see that we've added a delay. I'm not sure if we can see the actual timestamp, but anyways, so that's like another use case for an enumerator is adding this wait for seconds to add in a delay to something. So that's useful if you have, for example, say like an enemy is attacking or something like that at a set interval, or like shooting a projectile. You could use a coroutine to say like shoot something and then wait for a few seconds and then have it shoot something again, and just have that in a while loop like this. So that is running forever, but then waiting every few seconds. Because again, there are ways to implement that in update, but the nice thing about this is that you kind of decouple it from update and have it just as its own function. So that's the benefit of coroutines.
Can I just add, if anyone here does any games with dialogue, every single time I have a dialogue game, the classic way that I use these coroutines is I do that delay in order to get the text on the dialogue to like come out like one character by character, as opposed to having all of the UI update at once, which is something that I guess just like adds that bit of polish to your game. Which, because you don't want to just like update your UI with a single string all in one frame. You want it to kind of come out all at once, or not all at once. So bottom line is there are plenty of applications for coroutines.
Mm-hmm. Again, it's just like anything you want to spread over multiple frames, it's very useful to do a coroutine. Okay, so having said all of that, let's see.
Will a coroutine always run before update or fixed update?
I don't actually know what sequence they run it in.
That's a good question.
Yeah.
I also don't know the answer to that, but that could be important depending on your project.
Seems like it could.
So if anyone like knows the answer to that, or if they want to Google it right now, that is totally useful to know.
I think there's some way to look in your project settings to like determine the order of execution for things. I'm not sure off the top of my head.
Yeah, that sounds familiar.
So it might be listed
Normal coroutine updates are run after the update function returns, says the Unity manual.
Okay, that's good to know.
That is good to know.
For like certain edge cases. Cool. Any other questions? Keep them coming. This is helpful. Okay, I'll take that as a no. Cool. So now we have a basic idea of like different use cases for a coroutine. So let's try and do something a bit more fun with it. So we're gonna make a. Here, I'll just kind of show you what I have right now. So I have this other project open that I was like half working on before this. I'm going to duplicate this. So I was trying to make like a beehive that has a bunch of bees that kind of swarm towards the player. So if we watch here, what I have on here is like a bunch of these blocks that are just kind of moving to random positions around like this capsule that I'm just going to call a beehive. And then I didn't get to this part yet, but basically we're going to have it so that whenever the player is in range, the bees will detect it and then kind of run towards the player. And then once it's out of range, they'll go back to patrolling around it. So the basic AI loop is that they patrol around their hive. And if there's an enemy nearby, or I guess the player nearby, it'll go and attack it. And then otherwise it'll retreat back to what it's doing. So how we'll actually implement that AI is with a finite state machine. That's just kind of written out through code. There are a number of ways to do that in code and in Unity. So I'm just going to go with a simple example to kind of illustrate the concept. I will preface this with the fact that like the method I'm going to show you doesn't scale very well. So it's useful for small things like this when you can handle a bunch of different cases and kind of like draft it all in your head. But if you're doing like a much more complicated AI, you're better off using like a more complicated system. But I'll get to that more in detail once we actually write the code for it. But anyways, this is what we're going to aim to do. So let's start out by first defining a way for these little cubes to kind of act like a bee and spin around a hive. So let me just rename my cube to a bee first, just to get a little more thematic. And then I'm going to make them a little smaller too. So I'll do like 0.3, 0.3, 0.3. So that's our little bee. And let's add in a hive. So I'll just make a capsule for now. I'll put that at 0, 0. Oops. And then I'll call him hive. Cool. So actually, I'm going to move this guy over here for now. And we're going to do a couple things with this cube first. So let me pull up old code. Okay. So we're going to use enumerators, or sorry, not enumerators, coroutines to kind of simulate that movement of them randomly bouncing around the hive that I showed you earlier. So how we can do that is we can use this move to function that we already have and then combine it with another coroutine that we can define that basically calls this at random positions. So how we can do that, let's see. So a useful thing you can do with coroutines is you can actually yield another coroutine as a return value, which essentially just means that you're only calling a single thing, and that thing is another coroutine. So you wait for that whole thing to execute, and then you yield, if that sort of makes sense. I'll type it out to show you. So I'm just going to call our new function enumerator, and I called it move patrol. So if I can type patrol, there we go. And we'll just make it a void function and fill it in this way. So we'll just do a nice while true loop. And again, this is an enumerator, so we don't really, or I keep saying enumerator because I'm reading that. This is a coroutine, so we don't really care that it's a while true because it'll just yield to the next frame indefinitely. And we can also, one thing worth mentioning, if you want to ever kill this coroutine, you can call stop coroutine on that specific coroutine. So you'll need a reference to that coroutine, but there are ways to like kill this while loop if it's becoming an issue, which we'll use later. But anyways, what we're gonna do is we'll do let's do yield return, and then we're gonna call our other coroutine that we defined down here as our return value. Move to, and then I'm just gonna use let's do new 3. We'll just do this for now and replace this later. So we'll just center it on the origin. Plus, we're going to use random dot inside unit sphere. So this is just like a way, it'll generate a random point inside of a unit sphere. So it's pretty self-explanatory. So that's how we have it kind of bouncing around. So we're choosing just a random position in a sphere centered on this point. And then we'll multiply it by just create a variable called patrol radius. And we'll move at patrol speed. And then we should define those at the top of our function. Or of our class, pardon me. So we'll just do public float patrol speed, and then we'll just set it to like 5 for now. And then we can do a public float patrol radius, and I'll just set it to like, let's also make it 5. 10's a bit large. Cool. And now what we should expect to happen is nothing, because I haven't actually called this function yet. But when we call this coroutine, we have this while loop going forever, and we have a yield that calls this function. So essentially, it's going to call this coroutine and bounce into this function and do this whole while loop, and it won't finish running this while loop until this function has finished running. Which essentially means it will run this complete coroutine before yielding to the next, or sorry, it'll still yield, but it will run this complete coroutine before calling the next one, meaning that it has to move to the position, get there, and then the next position can be called. Does that sort of make sense? I kind of jumbled my explanation there, but it'll make more sense when I run it, I think. So I'm going to change this move to just be move patrol. And then we go in here. Oops, what did I do? Oops, there we go. Duplicator parentheses. If we run it, I canceled it. You can see now it just kind of bounces around in a random position. So again, what's happening here, let me do this if we look at our code here, essentially all we did was call move patrol, and move patrol is just looping this move to function at random intervals, just inside random points everywhere here. Does that make sense? Cool. Any questions on this? The key point to take from this is that you can use a coroutine to call other coroutines, and it will force it so that that coroutine that's being called has to finish before it can call another one, essentially. And that's just kind of like the syntactical sugar, as I think Eggert says that. But anyways, so that's really useful. But you might be kind of annoyed, like I was when I was testing this, that like you can't really see where this guy's bouncing around. He's just kind of randomly doing that. So I'm going to add in a quick little gizmo. So gizmos are nice little tools for debugging, especially in the editor, to kind of allow you to like see different things. So I'm just going to go back into my code really quick. And what I'll do is, well, first of all, I'm going to not make this the origin. I'm going to add in another variable for a, let's do vector3 patrol center or something like that. And then we'll just set it to 0, 0 for now. But that way we can change this later. So I will put this to patrol center. And the reason I want to do that is because I'm going to add in this nice little gizmo over here. So how you work with gizmos is you basically call them inside of a specific function. So if I do private void on draw gizmos, I'm going to do selected actually. So on draw gizmos just means that if you're in the editor here and you have gizmos selected here, which is just up in the corner, it will render everything that's a gizmo. So by default, it's on in your scene, but you can like also enable it in the game. So I'll keep it on draw gizmos just for now to show it, but you can also do on draw gizmos selected, which actually I'll leave it on this one instead. And what this one does is when you actually select the object in the editor, then it will render the gizmo. And then I'm just going to copy paste this line, but I'll explain it. So we have gizmos dot draw wire sphere, which like is pretty self-explanatory, and then this I have to change to our other ones. So I'll do patrol center and then patrol radius. So you just draw a wire sphere of a point and a radius. And now if we go back, I'll save this function and go back into our editor, and you can see whenever I have this cube selected, it'll draw a nice little wireframe around the origin, which makes it a little easier to see like where he's bouncing around. So now we know that he's going to be within this kind of radius here. So yeah, useful tool. It's also useful because you can do stuff like draw little arrays and stuff like that. So if you're ever like debugging with different stuff that involves just like simple shapes like this, it's useful to just like throw in some gizmos sometimes just so that you can visualize what is happening in your code. Anyways, that's just a little aside. Let's get back to the coroutines. So let's see. So we have our move patrol. So we have it bouncing around. We also want to have it attack the player. So we can still just use the move to function for that, which I think is what we'll end up doing. Admittedly, I didn't actually test this beforehand, so we're going to do this live. But let's see. Go to update. Where do I want to go with this 1 second? Look at my code. Okay, let me modify this code a little bit. So instead of just calling it on this vector3 center portion, what I'm going to do is I will make this, I'll add in a public game object, and then I'll just call it home transform, which is what I labeled it earlier. And then get rid of this. And then in start, I'm just going to do patrol patrol center equals cone transform. Right. Dot position, sorry. Oops. Cool. So what this is doing is this allows us to have just a game object in the script over here that we can just drop like our hive in, for example, and then it will get the transform from that hive in start so that it will then center the bee on the hive. So if I move this over here, you can see the bee should, oops, yeah, so it drifts over to now center around the hive, despite starting over there, which is kind of fun because if we go back into our scene here, and if I were to just like copy paste this guy a bunch of times, let me do this. We can see that we're just going to have a bunch of bees swarm over and kind of fly around our hive. It starts looking pretty cool. You can see, despite all this motion going on, we still have like upwards of 500 frames. So it's running pretty efficiently, which is good to know. Anyways, so now we have this kind of cool hive effect. I think, yeah, they're not going to follow because I have it defined in start. But basically, this allows us to define like a center point for them to kind of have as like their home base. Okay, and now there's a few different ways that we can implement detecting like if there's a player. So first, let me make a player object. So let's just add in, I don't know, I'll do sphere for the player. Let's put them at the origin. And then I'm going to move all these bees over. I'm going to get rid of most of these actually. I'll move our bee this way for now. And then I'm going to tag my player with player. So this is just going to be, pardon the pun, be our, God, I like lost my train of thought because I thought of that. This will be our player, and we've tagged it as a player. And what we're going to do is add on a collider to this box here. We'll just make it a sphere for now. What do I want to do? I don't want to do that. I want to do add component sphere collider. And we'll make sure that it is a trigger. And I'm just going to set the radius to like, I don't know, 8 or something. Does that look good? It's kind of small. Let's do like 10. So our plan here is that whenever the player enters this hitbox for the bee will switch its state to something that makes it so that it should attack the player. And we'll have it attack the player just by moving towards its position for now. And then we can add in more stuff later. But then we'll have it so that if it leaves that radius, then the bee will just kind of go back to its hive and then go back to patrolling. Cool. Any questions? Does that make sense? Cool. Okay, let me save, and then we'll go back into our code. So we have our sphere collider here. We're going to go back into our code, and now we need to have a reference to that sphere collider so that we can actually detect when things are colliding. 1 second. So we'll do a private sphere collider. Let's call it, I'll call it SC or something like that. And then in start, we're just going to add in SC equals get components sphere collider. So this should grab it from our object. And then that gives us a reference to it on the actual object. So now what we can do is, God, I'm blanking on this. It's private void on trigger enter, I believe. So now because we have our component here, we can use just on trigger enter to grab whenever something enters that area. And then we can do something like if other dot tag equals player, which we have on our player object here. Wherever I put it, let me rename him. I'm not going to add any movement for the player for now, because we've gone over that in other lessons, or not in advanced workshops, but I feel like you guys can figure out how to make a player move in 3D. So I'm just going to drag him around for now. But anyways, we can do if the other is player, and then we'll leave this blank for now because we need to go back to it later on. What we need to do first is actually set up some definitions for our state machine. So if you've taken, God, what class goes over state machines? I think like CS51A or whatever it is, M51A.
M51A, I think.
Yeah.
Yep.
Yeah. So if you're taking that, you'll know what a state machine is. If you don't, it's essentially just like a flow chart of like different actions that can occur based on like events in a system. That was a really awful explanation, but it'll make more sense. There's way more to it, but we're doing something pretty simple here, so it's not that relevant.
I'm just curious, is there anyone here who like needs an explanation of what a state machine is? Because if not, like we'll just move on. Okay, cool.
Cool. Okay, so what we're going to do to make our state machine is we're just going to use an enum, which is basically just like a variable you can use to define like specific, or it's you're defining your own variable essentially with like a finite set of states to it. That is also an awful explanation, but it'll make sense when I type it out. So we're just do a private enum. This is an enumerator, and then I'll do state as the name of it. And then let's see. So I'll add in, I want to have start patrol. Oops, I cannot type. Jesus. Start patrol, chase, and attack. So some of these are just kind of arbitrary for now. We'll get into more detail on like why we need these later. But I'll cover that in a second. And then we also want to have a private state, state current state. And then we'll also want, this will make more sense in a second, private I enumerator, header, current coroutine. Okay. So the reason we want this is so that we can have a reference to whatever coroutine is currently running, so that we can stop it. Because I had mentioned earlier, like if you want to stop like this while loop from running forever, which in our case that would happen if like the player enters our space, then you need a reference to that. So we're just going to use this to create that reference. So now we're just going to use a switch statement to an update to do all of what we need here. So I think I got rid of update. It's because we're becoming kind of messy. So maybe move update up a bit. I'll move it under start.
Sorry, could you pause like real quick and
Yeah.
just go back for a few seconds back to there with the state thing? Just thank you.
Sorry, I'm going kind of fast. Give me a break. Okay. So how we're going to implement our finite state machine is just with the switch statement. Like I had mentioned before, it's not the most efficient. Well, it's an efficient way to do it when you have like very few states like we do, because we only have like 4 that we're really working with right now. But if you get to a more complicated AI system that has say like 20 states to it, or like upwards of that, it's going to be really messy to manage all of that in one specific class, let alone like one switch statement. So it's better off at that point to kind of break up your code into like individual classes that you call for each individual state. Ours isn't that complicated though, so we can kind of get away with just doing a simpler system for now. If you have questions about like a more complicated system, talk to me after this, and because I also kind of want to look into that. But for now, we'll just do something a bit more simple. Anyways, on that note, so we're just going to use a classic switch statement, and then we'll do switch on current state, and bump this guy out. And then we'll start with case state dot start patrol. Wait. I'm just going to duplicate this guy. Oops. Cool. So I'm just using Control D there to make a bunch of copies. And then we'll replace all these with patrol, chase, and attack. Okay. So we'll start with start patrol. So the reason that I have a separate patrol and start patrol, let me actually just illustrate that by doing just patrol. So I'm going to do current coroutine. So again, that's just an enumerator that we defined up here, our current coroutine. And we're going to define it by just calling the function move patrol. So all this does is just make a reference to that function. And then we're going to start our coroutine on current coroutine. Cool. So how we'd expect this to work is that it would just call the coroutine and then it would start bouncing around like we saw before. But what actually happens is when we run it, my computer isn't lagging. You're going to see that the, let's see. Oh, it's not bugging out. Why is it not bugging out? Did I fix it unintentionally? What was happening earlier is that it would start bugging out because it essentially is like calling a new coroutine every single time it runs. Oh, you know why? It's because I haven't moved into this state yet. So I wanted to do, so I'm going to comment out these guys for now because we're not really using those anymore. And I'm going to set my current state to patrol. This is what I forgot to do. So that's why it was fine. I'll go back to the code for a second. So again, in just start, we set our current state to patrol. And then that should put us right in here in update. So it's going to just call the coroutine. But the problem is we're calling the coroutine every single frame. So you're going to see eventually the report little b just starts bugging out because every single frame we're calling a new coroutine. You can kind of watch the frame rate just dipping down to very slowly because, again, we're just calling a bunch of different functions. And then now this guy has no idea where to go. So that's the reason that I implemented this additional, where is my code? This additional start patrol so that we only call it once. So we're just going to use essentially like a dummy state that calls this once, and then we'll just set our state to state.patrol. That way we just have a way to call it once, and then as soon as it's called, it will jump into this other state so that it's not called again. Does that make sense why we do that? Cool. Any questions so far? Okay. So again, we have our, I'm gonna also set this to start patrol instead. So that way when we start it up again, it should just call that coroutine and then just go into the patrol state. So yeah, now it's working as we expect it to. And now,
what's that last thing you put down?
Where am I looking?
Last thing you wrote down, you said something, but I didn't catch it.
Oh, it's just working as we expect it to now. Cool. All good?
Word patrol doesn't look like a word anymore.
I also was thinking that when I was coding this earlier. I kept thinking I was like typing patron or something. Anyways. So now we have a couple of our states filled out. So we have our start patrol, and that just jumps us immediately into patrol. So how we can get out of patrol is with the trigger that we had added on earlier to this B. So it's that green outline that we have right there. Unfortunately, there's not a way to access it other than on trigger enter, which we had started over here. So it does kind of like break the cleanness of our code here a bit. So again, this is like a messy implementation that isn't something you should do if you're trying to scale it to something larger, but bear with me anyways. We're going to basically just have like an empty patrol state that is just kind of a dummy place for other things to happen to. This could be useful later on, actually, if you wanted to like implement an animation, for example, because you have like a pretty defined state, and then you could set inside of each of these what the animation is playing. So it is useful to have like these dummy cases in case there's other things you want to do like during these. But for what we're doing now, like this is just going to be pretty much empty. So we'll go to chase. So sorry, I'm like explaining this as I'm thinking it through. So where were we? So on trigger enter, we're just going to check if the thing that we're colliding with is the player, and if so, we're just going to set our state to what do we want to do? We'll set it to chase. Current state equals chase. Oops, state.chase. Cool. So that essentially jumps us out of whatever we're doing and puts us into the chase state. Similarly, we'll probably want to do something like this with on trigger exit. And then put it back into start patrol. Okay. So what we've done now is that whenever we enter that trigger, we'll go into our chase state, and then whenever we exit that trigger, we're going to just go back to patrolling it like we were. So when we enter our chase state, we no longer want to be bouncing around like we're patrolling. So what we can do is just do stop coroutine, or not stop all coroutines. We'll do stop coroutine. What am I doing? Stop I cannot type. Coroutine. There we go. Of current coroutine. Coroutine. There we go. And then we'll just pause it for there. So now what we should see, I'm just going to duplicate a bunch of B's again. Assuming I did this right. If we move out, now if I were to move my player closer to all these B's, they should just stop moving, and they're not. What's going on?
Just imagine getting close to a bunch of bees and they just freeze.
Which is what we should be expecting, but it's not happening.
Does your player have the tag on it? It does.
It does. All right, we're playing a classic game of spot the bug in my code.
Do you have like a collider on everything?
I do not. That's probably it. Oops, I wanted to delete that. Box collider, player. Wait, I do. Why is this not working?
Is your bees thing not a trigger or something?
Is trigger. All right, let's look at my code. Any ideas?
Do you need like a rigid body or something in order to activate the triggers?
That might be it. Let's try that.
Yeah, I don't remember if it's like on the player or the B or.
Try it on the. Oh wait, no, I don't want it on the B.
Why do you need rigid bodies to activate colliders?
Yeah, I feel like that's not the problem, but like, who knows?
Yeah, it's always something. We'll try it on that for now. Let's not use gravity. Okay, wait, was it that? Yeah, it was. Nice. Yeah, so now you can see when I move it in, the bee just freezes, and then when it leaves the trigger area, then it continues moving. Cool. So we've got part of it working, which is useful. So now we're essentially using our patrol state is again just kind of blank, but our chase state now pauses the bee and then allows us to now do something else with it. So let's just for now do something like call a coroutine on move to the player's current position. So let's add in a variable actually. We'll do a private vector 3 player pause. And when we trigger enter, we'll enter chase, and then we'll also set player pause equals other dot position. So we're just grabbing the position of the player when it detects it. Okay. I'm realizing an error in my head that's going to happen, but we'll play it out and then come up with a solution after. This is the part where I'm like, this is the interactive portion, as I had said earlier. So we'll kind of brainstorm different ideas of what we can do with this. AKA, I thought of the lesson up to here, and now we're just going to kind of wing it. So, anyways, so what was I thinking? Oh yeah, so we stop our coroutine, and then we'll just go ahead and start another coroutine for move to, and then we'll do player position, and I don't know, let's make it like way faster. So we'll make him move like, what is it? We'll do patrol speed times 2 or something like that. So he's like twice as fast. So what should happen is I'm going to make a bunch more bees. Let's make this interesting. Okay, so we should have a bunch of bees flying around our nest or hive, whatever it is. And as soon as I get in this area, they shoot right at it. That's really fast. Okay, that's a little aggressive.
They're like causing the thing to spin around when they hit it.
Yeah. Okay, that's kind of funny. So they're making a beeline for our player, which is good.
Oh my gosh.
God, I'm full of puns right now.
Nice.
That's quite good.
Did you like make this the theme of the tutorial specifically so you could say that?
This was an hour and 8-minute setup for that joke, guys.
I believe it.
All right, interactive time. How do you think we could solve this? Because we need the rigid body for the triggers, but we also don't want them to like
constrain the rotation.
Oh, that's a good idea.
Can't you also use it as a kinematic, maybe?
Let's try that. Nice, that seemed to work. Okay, so
What?
We just did the kinematic, and then now it doesn't collide. So you can see when it enters the area, the bees beeline for it, and then the problem is that they're going to the position that they detected the player at. So you can see, like, if I move him here, but then move it while it's still in the trigger area, they stay in the position that they'd shot to. So instead of using move to, we either can use another coroutine or just use the update function itself to have it shoot towards the player or do something else with it.
What was it? Is kinematic? What was up with that? Still a little confused there.
Kinematic basically means, well, there's 3 types of rigid body like settings you can have. There's static, kinematic, and dynamic. I believe by default it's on dynamic. And
I think so too, yeah.
If you don't have a rigid body, that means static, I believe. Because before, like, they updated it before. Now you can just take the rigid body off, and that means it's static. But basically, kinematic means you want to move the object yourself, but you don't want it to be affected by other things hitting it. Versus dynamic is like, this is something that is going to move like based off of like reactionary, as opposed to, you know, like you defining its movement.
All right, cool, thanks.
Cool.
And then static means that you like don't move it at all.
Mhm.
Okay. I'm trying to think of like a fun thing to do. So let's say like if it gets to a certain distance of the player, it'll go into an attack state and then it just circles around the player. Let's try and figure that out.
Don't you still need to solve the problem that it's going toward like where it thinks the player is versus where the player actually is?
Oh yeah, let's solve that first actually. How can we do that?
What's your move to? How does that work right now?
So move to takes in a position and then just goes to it. So if the player is moving during that duration, then it will just kind of stop.
Is it
Wherever
possible
it
for you
first
to
detects it.
pass in a transform rather than a like vector position? Because then you would be moving closer to that transform even after that transform were to like change its position.
We need a reference to the transform though, right? Not
Yeah,
okay.
you would.
You can try that.
So if you can put a player reference up in the top instead of a player position reference, or like a player transform reference rather than a player position reference.
Wait, no, that's not what I want. Where were we? What am I thinking? I think it might be better just to like, because we don't really want to touch this function too much, because then we'd have to like modify everything else. Let's just make a new enumerator.
Yeah. I think you can do like literally the same design except substitute vector 3 for a transform that you pass in.
Or sorry. Let's see. Yeah, I'm just we'll duplicate all this code for now. I don't need this here actually anymore. Let's see. What did we want to do? Oh, we need to pass in a reference to this, right? Is it still an ampersand? Wait, how do we?
I don't think that's how you do it in C#. You might want to just pass in the game object itself, because I forget how like passing transforms works. But if you do that, you would just have to like do dot transform. So I think you can probably do it the way you have it right now. Okay. You would say while transform dot position does not equal
destination
like destination dot position. I think that comparator should work in C#.
Seems to like it. Let's switch that to track move to. Let's also
Does everyone understand what we just did? Well, actually, let's test to make sure it works before we go.
Oh wait, I need to change this to
player transform.
Yeah. I still think it's only grabbing like the current value from it, right? Because it's.
I think it's a reference. I think it's a reference to the transform.
Let's just try it. What is the issue here? Oh.
Did you modify your patrol speed? Oh, that's it.
Where am I? There we go. All right, let's try this out.
I think you're gonna need to like reset. Oh no, I think actually it should work.
Yeah, it works. Nice. Cool.
The bees are inside.
The bees.
There are bees inside me.
It's kind of terrifying, actually. Cool. And then if I
That's like a cool visual effect. If you move it too fast, they all kind of follow it.
That's fun. That's got to be terrifying in real life. First, one day you walk up to the beehive and all the bees freeze, and then the next day you walk up there and they go inside you.
Yeah, Jesus. Okay. Oh, so now it's not
How
going
come they
back.
do that? Why do they go all slow like that?
Game
when
view
you
is
go in?
terrifying.
Let's see. Oh, you know why? It's probably because it doesn't end. We need to kill this coroutine when we exit. Because I'm imagining that what's happening is
It's like trying to move back to the hive, but also chase the player once.
yeah. Okay, let's suck them all up. And it's still not working. I do like this visual effect though. It's kind of cool. Any ideas?
Like this could work for energy particles, but the visualization of bees is just not doing it for me.
Yeah. The bees.
I think that the issue is like you're not stopping one of the coroutines at some point.
Yeah, I'd imagine that's it as well. Let's see. Move to.
As we mentioned before, like, you know, it's already turning into something that's a little unwieldy. So this whole switch statement is pretty Connor says, I don't think you update current coroutine.
Ah, that's it. Thank you. All right. Why is it mad? Oh. Okay, I think that should work. Good catch. Nice, that worked.
Wow, success.
Very nice. Cool. So now we can do something like, Jesus, it's kind of scary. Imagine if bees like actually worked like this, where they just like, if you got too close, they just immediately kill you.
They not immediately kill you. They go inside you and build a nest inside you.
Yeah, Jesus.
That's what the hive is. It's like someone.
Billion four.
I'm like having way too much fun just playing with that. Cool.
My bee is not working like at all. I think at some point I've been calling too many coroutines and didn't stop something.
Yeah, you can see how this gets like unwieldy if you're doing it the way that we're doing. So again, like we're teaching you bad practice here, so just be aware of that. All right, let me get rid of. I'm gonna get rid of my old project because I'm not using that anymore. We're off the script.
Can we see the switch statement, Mark?
Yeah. Sorry. Okay. Okay. What do we want to do now? Do we want to implement an attack state? Do we want to? What else can we add?
How come? Okay, I might be misunderstanding. Why do you set the current coroutine to move patrol and then immediately stop that coroutine in the start patrol state?
Right here.
Yeah. Is this like a dummy state or something?
This is a dummy state basically.
Okay.
Because what was happening before is that thing where it would call a bunch of coroutines and basically start bugging out. I guess it is already a bug, but I have too many jokes.
Why don't you have to implement a dummy state for chase?
Because it's only ever calling it on. Wait, that also doesn't make sense. A lot of questions popping up here. I think it's because they're all the functions are then like tracking towards the same position, so you probably could bug it out if you're like playing around with it too much. Let's see.
It feels like right now you'd be calling that subroutine a whole bunch of times.
Yeah, wait, let's just let it sit here for a second and see if like the frame rate starts dipping. That's usually how I tell. It seems to be fine.
That's strange.
Yeah, that is odd, because I think you're right about that.
So,
I clearly
can you
prepped
go down to your move patrol? I'm just trying to figure out why nothing is working on mine when mine seems identical to yours. Bee's kind of just glitching out once it starts moving. All right, it's identical. I guess I'll have to live with a non-functional bee.
Sad. Let's see. All right, let's just add in. I guess we'll do an attack state now.
Regardless of whether you can get your coroutines to work the same as Mark can, like as we said, we have some kind of bad practice in here in terms of the organization of the code. But the main takeaway that we want you guys to get is like how coroutines work. So
which I think we've hopefully covered.
That.
This is more just like a bad practice example of how you can use them. Not necessarily how you should use them. But you can see it is kind of fun. You can make some interesting stuff with like a lot of stuff going on, I guess.
What would your attack state be?
So I was going to add another collider that detects when the bee is close. I guess you could just do like if the bee is within some distance of the player, set it to the next state, and then I was just going to have it like orbit the player. Use like a sign function or something like that to cycle around the player. Let's try that.
Bye.
Let's see. Does anyone else have any other ideas as well? Because at this point, we're just kind of like, we're experimenting, if you will.
Are there any other ways you can use coroutines? I know I use it a lot for like the wait for X seconds thing. But
that's probably one of
there's anything else.
Bigger uses for it, honestly. Coroutines are useful when you need to do like computational stuff in the background too, like we had mentioned. Generally, the stuff we're doing in this club isn't that intensive that we need to use them, but it's useful to like know that it's a tool available. I like using it for motion like this, for example, because you can get like some nice smooth motion out of it that's like relatively easy to manage. I'm trying to think of like other examples that I've come across. I can't off the top of my head.
Pretty much anytime you want a while loop to like play out over the course of real time in your game, that would be a good time to use a coroutine. I guess off the top of my head, that might not be completely true.
Yeah, I mean, that's generally what I've used them for as well. Yeah.
So for instance, if we wanted to, oh, did someone have a question?
No, go ahead.
I was just gonna say, like, if you want to see, if anyone wants to see like another implementation of the wait for seconds thing, we could totally have like a, make the bees flash red when they're chasing you, that kind of thing. You could have like a wait for seconds where you change the color of the bee object like every whatever whatever interval you would like. I believe I don't know off the top of my head the other like coroutine things that you can call besides wait for seconds. I believe there's one that lets you wait for a specific number of frames, although I forget. Let me pull it up.
There's wait for seconds real time, wait for seconds, wait for end of frame, and wait for fixed update.
Yeah, so wait for fixed update is actually a great one because, as I'm sure you guys know, a lot of the time you want to use fixed update as your frame reference rather than the actual frame rate of the game if you're talking about anything physics related. So that would be an example of when if you're having some kind of issue when you return null, it might be that you actually are trying to do like a physics-based thing that's not gonna want to be tied to like your actual frame rate on your computer. I don't know the difference between wait for seconds and wait for seconds real time. That's something that's always confused me. Do you know that, Mark?
I believe if you're having like a low frame rate, it scales the actual time interval. Whereas so fixed update is off of like real time, right? But then update is off of frame rate time. So those are two separate time intervals that are being recorded.
So wait for seconds is actually not real time. It's based off of your frame rate. Is that correct?
I believe so.
Yeah, because you can like slow down time, and then
right.
Then real time will always be constant.
Mm-hmm. Because there's the like in-engine time interval that's used.
Is that the primary use for that? Like wait for seconds real time is to bypass the in-engine time manipulation? I
believe so. So that's useful, for example, if you have like something that needs to be like timing based for like a rhythm game or something like that. I've actually used stuff for that and stuff I've like tested with trying to make a rhythm game. Not this specific thing, but like using real time versus the in-game time. So actually, that's a good example of when you might want to use that. I'm trying to think of like other things. Honestly, this is more just like
question. How do you get statistics? Like, how do you get the statistics show
up? I believe that's just an option. Just hit stats on your game display. Should be the top right.
Oh, yeah, I see it. Dummy me. Thanks.
No problem. There's always a ton of just like weirdly hidden stuff like that. But cool. So yeah, I mean, I could just keep trying to code something in front of you guys, or we could kind of call it now. If you're interested, I'm kind of like down to keep playing with this. But
yeah, anyone have any more questions about like coroutines or anything else we've done before I like end the recording and we can just mess around?
This is kind of vaguely related, but thinking back to the wait for real time thing, I used it for like animations in the pause menu, because the way I did pause was like I stopped time pretty much. Is that the best way of making a pause menu, like stopping time, or is there like a more efficient way to do that?
That's how I usually do it. Because I like pauses physics as well, which is useful, but
it all depends on your implementation, and I think that that's like a valid implementation of it.
Cool. That's good. I don't want to change around anything.
Yeah.
I guess something, it's not really coroutines, but the random inside unit circle thing, I didn't know that existed. That's pretty cool.
There's a lot of like different cool stuff in random that's like useful like that. I think there's like you can get a random color, random inside unit sphere, inside circle, on unit sphere is also useful. A lot of this is useful if like you just need some random direction to like make something arbitrarily move, like we were doing here. But yeah, sometimes I'll just like read through the documentation on just like stuff like this to see what tools are available, and that's how I found that. That's how much of a nerd I am. I read through documentation for fun. God.
I wasn't gonna say it, Mark, but I was thinking it.
Okay, cool. I say we probably end the recording then we can just kind of mess around.
Last call for questions. All right.